All right, let's get into our presentation. So just to outline our presentation, first we'll describe the problem of timeliness in questions. We'll talk about our data set and approach. We'll talk about the motivations and assumptions we made for our approach, and the challenges and results we received as a result of implementing our approach. And this is just a rundown of our group members and the contributions they made. All right, so question answering is a fundamental task within natural language processing. It involves understanding a natural question and finding relevant information to answer it within a text, passage, or database. For some questions, the answer could be static and unchanged, and we'll refer to these questions as timeless questions. An example is, when was Ben and Jerry's founded? There will always be one answer to that question, regardless of when you ask it, and that is May 5th, 1978. On the other hand, some questions have different answers depending on the time they were asked, and we'll refer to these as timely questions. An example of this is, how many farms are there in Alaska? The answer to this question could change depending on the time, as the number of Alaskan farms could increase or decrease. So our project is focused on determining the timeliness of questions, that is, whether a question is timely or timeless. And this can be useful for applications such as home assistants and chatbots answering natural queries. So before we describe our approach, some details about our dataset. We use Google's NQ, or Natural Questions dataset. It consists of around 323,000 anonymized natural questions asked on Google search engine. Each question is associated with a full Wikipedia page, and annotators have located long and short answers to that question within the page. The NQ dataset is useful for open domain question answering tasks, essentially reading through the entire Wikipedia page with no context, sifting through the details, and finding the desired answer.
Hi, I'll be going over the overview. So basically, given our data set full of NQ questions and its associated Wikipedia articles, what we'll be doing is we'll use a pre-trained model. In this case, it's BERT Squad. We chose to use a Squad pre-trained model because a lot of the Google NQ models are just really difficult to work with and very hard to modify. So what we do is we basically given a Wikipedia article and a question, we basically feed that into our model to get a prediction of the ground truth. And then what we do is we check if the ground truth fits with what we predicted, and if it doesn't, then we just throw that question out, because we don't want to deal with any questions that our model cannot even answer, because we'll be predicting a lot of answers from them. And what we'll do is, given a set of time periods, we'll grab a Wikipedia article from that time period, and then combine it with the question, and then feed that into our BERT model to get a predicted answer for a given time period. So we'll have a 2010 answer, a 2014 answer, and so forth. And what we'll do is we'll basically just check each of the answers to see if it changes over time. And basically the motivation and what we're actually doing when we mean check if they change is what we'll be doing. We'll calculate a sort of distance between strings. And what we'll do is we use this fuzzy wuzzy Python library, and basically it uses the Levenshtein distance, which is the smallest number of single character edits, insertions, or deletions to convert one string to another. And we basically want to see how does this distance change over time instead.
So the next thing that we wanted to talk about were assumptions, and they are as followed. So we assume that the BERT Squad is generalizable to the NQ dataset and will consistently perform regardless of the year. Timely questions will have an answer that changes within 10 years, and the answer will be found within the first 25 paragraph tags of the HTML. And differences in Levenshtein distances between answers and the original translate to differences amongst the answers, which is worded a little confusing, but we'll go over it more soon. And when following this methodology and these motivations and assumptions, the resulting data frame with these columns came out of our model, and we have these average scores for those different Levenshtein distances for the different years. And what we found was that the BERT Squad model wasn't perfect at generalizing to the NQ dataset, and that was captured by this fourth column of average score original, which said even when using the HTML provided by the NQ dataset, the model was unable to produce an accurate answer in comparison to the ground truth provided by the NQ dataset as well. And after filtering out redirects, no pages, and an average score original of over 70, we ended up with 3,916 questions. With this output, we define change over time as the range of Levenshtein distances amongst all the different edits and years. And this is where that wordy assumption comes in, because these average scores and distances are comparing all of these different year answers to the original, and they aren't comparing them with one another. But since it's anchored similarly, we assumed that in taking the range and taking the max of 90, subtracted or 14, the minimum subtracted from the maximum to get 76 as our max min, we use these calculations to say that large ranges are indicative of timely questions and change over time, while smaller ranges are indicative of timeless questions.
So now we're going to look at some examples of timely questions. So if you look at this last one, it asks who is going to host the 2024 Olympics, and you can see that the answer currently is Paris, France. Now, if you look at 2010, you can see that the bid isn't actually announced until 2017. So in 2014, the answer is still not there, and you can see that the final answer actually shows up in 2018, where it says Paris from 2 to 8, the 2nd to 18th August 2024. And if you look at the average scores, you can see that the range between them is quite large. Now, if we go to the next slide, in timeless section, you can see again in this last example, when what year did the last Civil War veteran die? You can see that the answer for that is 1956, and that the model correctly guesses or correctly has the same answer, and so you can see that the change by looking at the average scores is 0, showing that this is a timeless question, and that is the case for the rest of these questions as well.
Now we're going to go over some of the errors that we saw in our analysis. The first example is a false negative. This is because the question is timely, but it is predicted as timeless. The question is asking, how many wins does Brazil have in the World Cup? And all the answers are 5. This is true, but this is so it is classified as a timeless question. However, the last time Brazil won a World Cup was in 2004. So this is a false negative. The second example, the question is timeless, but the answers that the model returns for each of the years vary, which means that it is predicted as a timely question. The question is asking, when did the story To Kill a Mockingbird take place? All the answers are different, which means that it is classified as a timely question. However, in this case, it is not a timely question, which makes it a false positive. The last example here is our content-related errors. The question, what percent of Germany's energy comes from solar power, returns a bunch of different answers, which are all different statistics that the model tries to look for in the Wikipedia, which makes it a content-related error. In conclusion, when our pre-trained model was able to get correct answers to all the questions, we were able to detect timely questions properly. However, if our model failed to correctly answer questions, it made it difficult to classify the timeliness of the question. In an ideal case, our approach would have had good precision, but would have poor overall recall because there were many timely questions whose answers didn't change within 10 years. So using a better model could give us more consistent and accurate results. Thanks.